Welcome to week 6, and here we have question 1, marginal analysis. And the question reads, the profit in $1,000 from the sale of X thousand watches is, you're given P at X. Now a marginal analysis can be taken for cost function, revenue function, or profit function, as you see there in the bracket. And a marginal analysis just means the cost or revenue or profit from producing and selling one more item. Okay, so one more. And we know from our derivative words that marginal we can equate with taking the derivative, so one more. So here we have P at X, and let's examine the function to see what we're dealing with. Remember, we have exponential rule for taking derivative, we have power rule, we have log rule, and so we need to look at the type of function we're dealing with. And we also have combinations of those types of functions. So we have sum and difference, product, quotient, and so on. So in this case, we have a sum and difference. We have terms which are separated by subtraction or addition signs. And we have 4 terms. Let's count them out. We've got 1 and 2 and 3 and 4. And each term here, we've got term 1, we can see that it's a power, it's x squared. Term 2 is also a power, x to the 1, although we don't write a 1, it's implied. Term 3 is also a power, x to the power of 0.2. And term 4 is a constant because there's no variable here at all. So let's remember the power rule. If we have x to the n, the derivative is nx to the n minus 1. Okay, so we're going to keep that aside to remind us. And let's go ahead. So if we look at part A, it says find the marginal profit function. So we're going to take the profit function here. We're going to take the derivative in order to find that marginal profit function. Okay, so P prime at X, that means that it indicates the marginal profit function. So we have the first term we're going to deal with, it's 0.8. We have 2, that's the n, we're bringing down as a multiplier. Then we have x to the n minus 1, so that's 2 minus 1 is 1. The next term we have is negative 3x, so we're going to be left with the negative 3, because x to the 1, and then minus 1 will be 0, and any exponent to the 0 is 1. And then we're going to have plus 5 times 0.2 x to the 0.2 minus 1. So we're going to have a negative exponent here, negative 0.8. And the last term, term 4, is negative 5200, which is a constant. And the derivative of a constant is 0. So we have a 0 term there in our marginal profit function. So let's tidy this up a bit. So 0.8 times 2 is 1.6x minus 3 plus, now we've got 5 times 0.2 here, x to the negative 0.8. So 5 times 0.2 is 1, so we just have x to the negative 0.8. Yeah, so that's our marginal profit function. Okay, so if we look at part B, it says find the marginal profit for x equals 100, x equals 1,000, or x equals 3,000, and x equals 6,000. Okay, so what we do then is we're going to substitute for x equals 100, for example, we're going to substitute 100 for every x variable we have in our marginal profit function. So if we do that, we're going to be writing this minus 3 plus 100 to the negative 0.8. And when we solve that, we're going to have a value of 157. Okay, so remember that the profit is in $1,000, so that 157 actually represents 150,000, and it's for the production, or for the sale, sorry, of 1,000 watches. Okay, so for x equals 1,000, x equals 3,000, x equals 6,000, you simply repeat the substitution using those values for x. If we look at part C, where it says interpret p prime at 100 using simple language, so what we're looking at is what does that actually mean? How do we interpret that? So p prime is the marginal profit, and you'll remember earlier in the question I said that the marginal profit is the profit from producing one more item, or in this case 1,000 more items, because it's x thousand watches. So the marginal profit for producing 100,000 more watches is $150,000. Okay, and that's how you'd interpret it. Thank you.